Okay, as we continue with probability, let's look at number 10. As part of an assignment, Andy, Bob, and Charlotte independently asked every student at ABC school how many aunts and uncles he or she had. Which of the following represents a valid probability assignment? Here's a probability assignment. The probability of 0 aunts and uncles is 0.1, which is 0.10 or 10%. The probability of 1 was 15%. The probability of 2 aunts and uncles is 0.2. Probability of 3 aunts and uncles is 0.25. And then the one that takes the rest, the probability of 4 or more, is 0.40, 40%. Well, let's see. They're all greater than or equal to 0. They're all less than or equal to 1, all the probabilities, so that's good. And if they want to cover all the bases, which this does, all the probabilities possible have to add up to 100%, or 1.0. Let's see what we get. 0.1 and 0.15 is 0.25, and this 0.25 would give me 50%. These three right here add up to 50%, so this should add up to 50. But it doesn't. It adds up to 60. So that adds to, I believe, 1.1 or 110% if you want to look at it as a percent. They need to add up to 1.0 or 100%. So this is not a valid probability assignment. The next one, well, this one will be very easy for us to determine that it is not. I don't know if they all add up to 1.0 or not, or 100%, but it has a negative probability. That's impossible. Probability cannot be negative. Every single probability is from 0 through 1. So that's not a valid probability assignment. And then this one, my guess is it will work fine. They're all between 0 and 1, that's good. And if we add them up, we get 0.1 and another 0.1, that's 0.2, plus 0.15, that's 0.35, 0.35 plus 0.25, that's 0.70. No, it must be 0.60. Let me double check that. 0.1, 0.2, 0.35, yeah, 0.60, and then the 0.40 makes it add up to exactly 1.0. So this one is good. It is a valid probability assignment. The first two were not. All right, number 11. The sample space of an experiment is this. Those are the only possible outcomes. You get a W, an X, a Y, or a Z. And the probability of W is 0.35, 35%. Probability of X is 0.15 or 15%. Probability of Y is 0.22 or 22%. Probability of X is 0.28 or 28%. Find the following probabilities of these events. Notice this is in squiggly brackets, so WZ is an event. It's a subset of the bigger set, the sample space. So it's an event. So all we need to do here is note that that's the probability of W plus the probability of Z. And let's see, W is 0.35. Z, this is a Z right here, that's a typo. The four events W, X, Y, Z. So the probability of W is 0.35. The probability of Z is 0.28, and that adds up to 0.63. You can double check me on that. And let's see, then this one contains 3 events. So that's going to be equal to the probability of W plus the probability of X plus the probability of Y. And we'll have to add those 3 numbers up. Probability of W is 35%, 15%, that's 50 total. Then add in the probability of Y, which is 22%, so that would be 72% or 0.72. Now notice on this third one, the event is the entire sample space. Well, what's the probability that any one of those four occurs? Well, they're the only possibilities there are, which means this, and this will add up to 1, or 100%. So that's equal to the probability of W plus the probability of X plus the probability of Y plus the probability of Z. And that's 1.0 or 100%. Because remember, the probability of the sample space is always equal to 1. Number 12. An ice chest contains 3 brands of soft drinks in 2 sizes. Actually, it's not 2 sizes, it's 2, we'll call it 2 types. Regular and diet. It's not large and medium. So it's 3 brands of soft drinks in 2 different types. If you randomly choose a drink from the chest, the following table shows the probability of each brand and type being selected. Okay, so you'll have to trust me on this or just add them up. All 6 of these numbers add up to 100% or 1.0. So for example, the probability that you get a regular Pepsi is 5%. The probability that you get a diet Pepsi is 10%. Coke, Diet Coke, Dr. Pepper, Diet Dr. Pepper. So what's the probability that the drink is Dr. Pepper? Well, it doesn't specify regular or diet, so we have to count up all of the Dr. Pepper column. And that would be 0.53 or 53%. I will write it as 0.53. You can write 53% if you'd like to. How about the probability that it's a diet drink? Well, that means it could be Diet Pepsi, Diet Coke, or Diet Dr. Pepper. So we have to add up the whole diet row. And that would give us 10 and 17 is 27, 37, 47, 57.57. Or 57%. What's the probability that it is not a Coke? Well, here's the Coke column. So we have to add up the other 4 probabilities, which would give us 15, 45, 55, 65, 68. 0.68 or 68%. Now, a way that we could have done that, maybe saved a couple of seconds, was find out what is the probability of getting a Coke. And if you add those up, either regular or diet, you are getting 0.32, 32%. That means that the probability of not getting this would be 100% minus 32%. And that's where this 68% came from. 68 and 32 makes 100. What's the probability that it is not a regular Pepsi? Here we really ought to do the shortcut that I suggested. The probability that it is a regular Pepsi is 5%. Therefore, the probability that it is not that is going to be 95%. So I'm going to do 1 minus 0.05, or 100%, minus 5%, and that gives me 95%, and this would give me 0.95. So that's a little trick that we will talk more about in the next section.